So this is exam to review. So you have your exam coming up next Wednesday, right? 24th. So this exam will cover after your first exam. That is, it will cover homework 10 through homework 15. And all you need to do is go over these practice exam 2 questions, right? So all your questions on the exam will be from this set. And then, so let's do a review. So what's new, what's the most important recurring feature on this exam is distribution, right? You'll see distributions after distributions. So let's go over the basic idea of distributions here, and then we'll dive into your actual questions. Okay? So you see, so the most common distribution is this bell-shaped normal distribution, right? So this is a normal distribution. So in the right here at the center, it has mean mu, right? And the spread or deviation is measured by this sigma called standard deviation. So many data sets, like most data sets in real life, also follow this kind of distribution, this kind of pattern, right? If you draw a histogram, but that's data set, it will follow this kind of pattern. Most data sets will lie in the middle, right? The average, so majority is the average, and then very few, on the low side, and very few on the high side. So that's a normal distribution. And for a normal distribution, what you need to be computing on this exam is scores. So these values are called scores, right? So here x, so these are scores. So here is one score or one x value, and then corresponding to this x value, you will have what's the probability of getting values lower than this value, right? So that means the probability is computed by computing the area under this curve to the left of this point, right? So, all right. So right here, so this area here is the probability, right? So this area, so this is the score, and this right here is the probability. And throughout this practice exam 2, you will see that you will need to compute both, right? So given a probability, sometimes you need to compute the score, sometimes the other way. Sometimes you are given the score and you need to compute the probability, right? And that's a normal distribution. And so that's for a individual data. So if it's a population distribution, right? It's a population distribution, and your question is about an individual. This is the distribution you will use, individual. Now, if the question switches from an individual to a sample mean, so now the question is about a sample mean. Sample mean. Then you will switch from this distribution, this population distribution, to sampling distribution. Okay. Still normal though, still normal. And still the same mean, but the standard deviation is going to be different. It will be divided by square root of n. And this is called standard error, actually. So, and the same computation you will do, right? Given a score, now in this case the scores are sample means. So given a score, like say, let's say this score here, you will need to find whether or not this score is, you know, a usual score or extreme score. See, if this probability is less than 5% probability, then you will say that this score, this sample mean is very unusual, right? This is probability. So you will need to be absolutely clear about the scores and probability. So that's a probability, this is a score, right? And how do you compute scores and probabilities in StatCrunch? In StatCrunch, you will use stat and then calculators and the distribution name. Distribution name. Okay, whatever distribution. So these are both normal distributions. You need to enter the mean value and standard deviation, and you can compute probability corresponding to a score, or vice versa, score corresponding to a probability, right? And by default, when you choose stat calculators normal distribution, by default it will give you a standard normal distribution which has mean 0 and standard value, standard deviation 1. This is called Z distribution. It's a standard normal, right? It's a standard normal. Okay. And on this exam, you will also see another distribution which is called a T distribution, which looks like, well, actually, it looks like Z, but only a little bit flatter, okay? It looks like this, actually. Looks very much like Z because it also has 0 mean, but instead of standard deviation, you'll have degrees of freedom here. So degrees of freedom, DF, is called, is sample size -1, n -1, and this is called a T distribution. And you, again, with this distribution, the goal is the same, right? Computing probability given a score, or compute a score given a probability. All right, so let's do a couple of questions like these to get started. And then, of course, there are other kinds of questions like confidence interval questions. We'll go to that. So let's begin with question number 6 here. Find the indicated probability using the standard normal distribution. That means Z, right? Standard normal Z. So you need to go stat, calculators, and normal, and by default it will give you standard normal, which means 0 mean, standard deviation 1, and use this score here, this Z score 0.97, to compute the area to the left of this score, or the probability of in other words, what's the probability of obtaining a Z score less than 0.97. So in other words, we are looking at 0.97 is somewhere here, let's say, right? So that's 1. So 0.97 would be somewhere here. See that? So what is this blue area, right? And how do you compute that? Well, if you use this table, it will take forever, right? Don't use tables. So if you go through this view and example, it will teach you how to use a table. And that's what I'm telling you to avoid. Instead, go to StatCrunch, stat calculators, we are using normal, so go to normal, and you will see exactly this picture here. So we are looking for this blue area. So on StatCrunch, it's this red area. So we want 0.97. So this red part, right? And you'll see the answer on this side, right? So don't get confused, okay? The score goes in this box, probability goes in this box, right? So if you want to find the probability corresponding to a score, supply the score here and hit compute, and it will compute that value, probability value in there. So, you know, alternatively, I mean, by contrast, if you want to find the score, then you need to supply the probability value here, right? And then hit compute. And that will give you a score in this box. So this is the score box, this is the probability box, right? So don't get confused. So students often get confused. So this is the answer. This is the probability. And round to 4 decimal places, and it's going to be 8340. Clear? All right, let's do one more. Number 11, where it's the opposite now, right? Now you see, now it wants you a score, right? So it wants you a score corresponding to the probability area this, right? Or the cumulative. Cumulative means all the way from the left end. That means cumulative means from negative infinity to that point. So same question. Now we're still doing z distribution, but we want cumulative area, this one here, 0.0571. So since that's the area, you'd put 0.0571 there, right? You see? So that's the box for the area. And you hit compute, and that's the score we are after, right? So that's the score, and the score goes here, and round that to 3 decimal places, and it's going to be 580. Okay? See that? How easy it is? Yeah. Yeah, sure.
On last number 6,
Mm-hmm.
my score was 1.41.
Oh, you were doing the same question or a different
Number 6.
number 6?
Yeah. When I rounded off the 4 decimal class, you have to round up, or it was to 3.
Round to 4 decimal places, it says here.
Okay.
Okay.
My probability came out to 0.92.
So which one? What is your score?
1.41.
1.41. So you mean this one, 1.41.
All right. That's what I got, but it marks me wrong.
And did you check the direction? Was it less than or bigger than? So you also need to pay attention to the direction, which side.
It's less than.
It's less than,
That's what I did wrong. Never mind.
okay, all right, good.
The negative number.
Yeah, all right, so now let's look at, now you see the same idea carries over. This is the same idea continues when we are computing confidence intervals. So the only thing that's new is for confidence interval, we need to use what's called critical values, okay? So whether we use a z distribution or a t distribution, we need to compute critical values. So critical value either zc or tc, right? Corresponding to a confidence level corresponding to confidence level C. Level C. So what that means is the middle area is C, right? So for example, let's look at this critical value. Let's see, problem number 46 here. It says find the critical value TC for the confidence level 98%, right? 98% confidence and sample size 24. So what that means is sample size 24 means this degrees of freedom is 24 minus 1, 23, right? And then what we are looking for is we are looking for that value which gets you this 98% area in the middle. So there is this TC. So we are looking for this score. And this will, by symmetry, this will be negative of that, right? Because it's symmetric. So we are looking for this critical value. So whenever it says find the critical value, that always means a score. Find this score so that that score and the negative of that score in between the caps are exactly C area, right? 98% area. So what do you do again? Same calculation, right? Stat calculator's distribution name now is T. So stat calculators T. See that? And now enter the degrees of freedom, which is 23, and the area so that you can find the score. And you know that since it's a in-between scores, so switch to between tab here, and that area should be in this box because that's the box for the area, right? And then degrees of freedom is 23, and that will give you that critical value, right? All right. So round to the nearest thousandth, so tenths, hundredths, thousandths, it's going to be 500, right? Okay. You see how we need to switch between these two kinds of computations. Given a probability, find a score. Given a score, find a probability, right? It's a constant computation, right? It's a constantly recurring computation that you will do on this test. Not on this test, but also for after this test, second exam. So everything after second exam is going to be hypothesis testing. And they are all based on these distributions. So it's a very basic, the main idea, right? The main idea that's constant throughout this semester. Okay, so all right, now let's move on to another question. Let's see, number 13. Okay. All right, look at this question here. The time spent waiting for a kidney transplant for people ages 35 to 49 can be approximated by the normal distribution as shown in the figure to the right. What waiting time represents the 85th percentile, right? what is an 85th percentile? It's nothing but when this probability is 85, you call this 85th percentile. Right? The score below which there is exactly 85% of data is called the 85th percentile. So again, same computation, right? So since it's a normal distribution, now we need to go to stat calculators, normal. And this one is not standard normal, right? Remember, standard normal is mean 0, standard deviation 1. So here we have a different mean. We are told it's 1667 is the mean, and the standard deviation is 207.5. 207.5, and we are looking for 85th percentile, means the area. See, this is the area box, okay? That area is 85.
And I can't see the mean.
667.
1667. And standard deviation is
207.5, yeah. And since we are looking for 85th percentile, which is a score, we are looking for a score. Make a clear distinction, okay? Don't confuse, don't mix these two boxes. This is a score box, this is a probability box. So we are looking for 85th percentile, that means this score. So we put 85% area on this side, and there it is, that's the score here. Right. So that is 1882, rounding to an integer. See that? The waiting time that represents the first quartile. What do we need to do? What's the first quartile? Very good. Excellent. First quartile is the same as 25th percentile, right? So it's 1527. All right? You see that? So that's how you compute probabilities and scores, right? Using distribution. And it's StatCrunch. It's always stat calculators and distribution name. All right. Now let's let me move on to another one. Okay, so let's look at problem number, let's see. This one here, number 30. Number 30, okay. Now this one is a binomial distribution. You see, again the same thing. Stat calculators distribution name is binomial. But we don't use binomial. We approximate it using a normal. Okay? So binomial distribution looks like this. It's a continuous distribution. And it's a discrete distribution. It's a binomial distribution. That's normal, but this is binomial. But it looks like normal, right? The only difference is it's discrete, right? It has heights. So it also has a mean. This mean in this case will be n times p, and this, so we can approximate it by a normal distribution using this kind of green. So we approximate this by normal. Okay? Binomial distribution approximated by normal, its mean is going to be this n times p, and its standard deviation is going to be n times p times q, square root of that. Okay. But we can do so, we can approximate only if satisfies that criterion, these two criteria. Yes, because both NP and NQ, if both NP and NQ are more than 5, greater than or equal to 5, then we can make this approximation. Otherwise, we have to use binomial. Okay? And we can use binomial, right? There's no, because StatCrunch also has stat calculators binomial in here. And for the illustration purposes, I'll show you both computations, right, on this question. I will use these blue bars, that's a binomial, and I will also use this green curve, which is normal. And you will see that the answer is kind of same, right? Not exactly same, because the one is the approximation of the other, but they will be almost, they will be very close. So let's see. So how do I know? First of all, how do I know it's a binomial distribution? Because I'm given n and p. So when the question gives you mu and sigma, you know it's a normal distribution. Instead of mu and sigma, if the question gives you n and p, then you know it's a binomial distribution. How do, where are those n and p's here? Well, right here. A survey of adults found that 84% of those who text on cell phones receive spam or unwanted messages. See that 64%? That's a success probability. That's P. Right? You randomly select 100 adults, that's N, who text on cell phones. See, you have N here, the number of people you are surveying, or that's the sample size. So that's N. And you have P, which is the success probability. And success in this context means who text on cell phones and receive spam. Okay? So you have N and P. So that's how you know we have this blue bar, right? We have a binomial distribution in our hand. Okay. But we can see that it satisfies those criteria, so we can use normal. Okay? So if you can use normal, then you have to use the green one here. So let's see. So in order to use normal, then we need to find mu, right, which is n times p. So n is 100. What was P? 60.64. So mu is 64, right? What is standard deviation? Well, it's n times p times q. That is, so n times p is 64 times q is the complement of p. So if success probability is 64%, then the failure probability is 36%, right? So q is 0.36, and in StatCrunch you can just use SQRT like that, right? N times p, this times q, square root of that. Make sense? So that's how you can use a normal distribution, by using mu n times p and sigma square root of n times p times q. Okay? And let's see, what does it say? Find the probability that the number of people who receive spam or unwanted messages is exactly 66. So this is 64, this is 65, this is 66 right here. So we are looking for this height, right? 66. So if you use the binomial distribution, you can just find the height of that bar and that's your answer, right? But if you are using a normal approximation, then you have to do this area under the green curve. And for this continuous curve, it's not exactly 66. 66 is right there, but this one is 65.5, and this point is 66.5. So you need to expand. You need to expand the end point, right? End point by 0.5 on either side, right? So for binomial distribution, it's just 1 point, 66 right there. But for continuous distribution, you know, there is no height. There are only areas, right? So that's the distinction between these blue heights and green areas, right? So areas don't have heights. They have regions and areas. So in order to change this 1 point into an area, you need to expand it by 0.5. So also, one of the rules of approximation is expand by 0.5. Expand either end by 0.5. Either end by 0.5. So just 1 point, 66 gets expanded by 0.5 on this side and becomes 65.5, and on that side it gets expanded by 0.5 and becomes 66.5. So we'll be looking at this green area. Are you clear about this, everybody? So for a normal distribution, our mean is 64, and standard deviation is SQRT, 64 times 0.36, right? And we are looking at the area between 65.5 and 66.5, so we need to switch to between, and 65.5 and 66.5. Clear about that? That's what you need to compute. I hit compute, and that's this strip, right? The area of that strip, this green strip. Make sense? round to 4 decimal places, and it's going to be 0.761. See that? Now, the problem doesn't ask you to use binomial, but let's say it failed, right? Let's say this criterion we used failed, right? If either NP is less than 5 or NQ is less than 5, this fails, right? Then you cannot use normal approximation. You have to use binomial. Then how do you use binomial? Well, it's also in there. Stat calculators binomial right there. See that? So, and then here you see these are bars now, and your N is 100, your P is 0.64, and then we are looking for exactly. So see, in this case you can do exactly 66, which is this bar right here. See that? That's the blue, the height of the blue bar. So that's how you would do it if the criteria fails and you cannot make an approximation of binomial using normal. Clear about that? All right. Okay, so so I think the other parts are pretty easy here. So yeah. So clearly that's the picture here, and another part is says find the probability that the number of people who receive spam or unwanted messages is at least 66. So at least 66 means what does that mean? At least 66. So let's go back to normal because we could. So in that case, we were able to approximate using normal, right? SQRT. Okay, now tell me, what does at least 66 means? What do you mean by at least 66? So what kind of area are we looking at? At least means, yeah, that and more. So what do I put here? 66 if it were binomial, right? See, for normal you need to expand by 0.5. So what would that be? 65.5, right? Because if you did 66.5, you didn't expand, you lost 0.5.
Can I see the questions I can write down the numbers so I don't plug them in? And we're on part, which part?
Oh, we are down here. Yeah. At least 66, it says. And
So you chose.
and then we did greater than or equal to 65.5 there. Right? So
The mean or standard deviation, right? We left that the same.
yeah, it's the same, yeah. That's the mean, that's the standard deviation. Yeah. Okay, so that's the answer. round to 4 decimal places. Okay, so that is this picture here, 65.5 and more. And one more, fewer than 66. Okay, go ahead and compute it. So what do you think, fewer than 66, what would that area look like, fewer than 66, on the normal side? So the mean and standard deviations are the same, fewer than 66. So what do I need to do? How do I change this area? Fewer than 66. Less than or equal to what here?
66.5.
Think about it. It's a little tricky. It's a little tricky. Fewer than 66 means 65 and less. See that? And then 65 expands 65.5. Yes. So it will be 65.5. So that's the, you see, it says fewer than. Instead of fewer than, if it said, you know, at most, then you would have to use 66.65 there. Right. At most includes that endpoint, and fewer than does not include that endpoint. Round to 4 decimal places, and it's going to be 7. And the picture is that. And it's saying if any of these events are unusual, and you check whether or not it's unusual by looking at the probability value, right? Anything less than 5% probability is unusual. This is usual. This is usual. That's usual. No unusual events.
Because it's all greater than 5%.
Yeah. All right. You see, the central idea is this, right? Everything comes back to the very same central idea, finding either probability corresponding to a score or finding a score corresponding to a probability, right? And you could be using a general normal distribution, population normal distribution, you could be using sampling normal distribution, you could be using standard normal distribution, you could be using t-distribution, you could be using binomial distribution, or the normal approximating a binomial distribution. See, lots of different cases, but the central idea is the same in all this. All right, let's see. Now let's go over problem number 20. Let's look at problem number 20. Okay. Questions?
At the very beginning, where did the 66 come from?
The 66?
Yes. So the defense problem is back to 64%.
Survey of adults.
Yeah, it was part of the question. So it wanted to find the probability of getting exactly 66. So this mean here is 64, so I'm saying that's 65 and that's 66. Yeah, it was in the problem. Yeah. let's look at this question here. The graph of the annual snowfall distribution for a particular county is shown below on the left with its mean and standard deviation. Assume that a sample size of 225 is drawn from the population. Determine which of the graphs would most closely resemble the sampling distribution. See, this is the sampling, right? Sampling distribution has standard error as its standard deviation. Population had just standard deviation. Sampling has standard deviation divided by square root of n. Okay, so what do you think? What do you think? It's pretty straightforward. So there is the population distribution, which is not even normal, right? And that's the magic part. Do you remember? Even if this is not normal, even if the population is kind of like skewed as it is in that picture, magic happens and this always is normal because of this adjustment, right? Okay, so what do you think? So mu should be the same, right? Mu should be the same. So the mu is 4.6 there. So actually that is a different mu. So this is out. So those two have the same mu, 4.6. What should be the standard error? Which is the correct standard error, A or C? Which one? Yeah, just use your calculator. Divide by the square root of n, right? What do you get? That's C, right? Can you see? Okay, 0.16. Everybody got that?
And that was the formula that we were using.
Right here, standard error, right? Okay, the graph most closely resembles the sampling distribution of the sample means. Mean is 4.6 and standard error is 0.16, and the graph approximates a normal curve, right? Clear about that? Very good, very good. So this magic is known as this central limit theorem in statistics, and it's the most important theorem in all of statistics, right? And this is the reason why normal distribution is used all the time, right? Even when your population is not normal, we could use normal because as long as the question is about the sample mean, and that's what it is, right? Most of the time, your interest is in the sample mean, not an individual, subject. As you'll see in this next question here, question number 24. Okay. Okay, let's read through this. Your lumber company has bought a machine that automatically cuts lumber. The seller of the machine claims that the machine cuts lumber to a mean length of 9 feet, 108 inches with a standard deviation of 0.4 inch. assume the lengths are normally distributed. You randomly select 43 boards and find the mean length is 108.11 inches. Assuming the seller's claim is correct, what's the probability that the mean of the sample is 108.11 inches or more? You see that the key word here is mean of the sample, right? That's the key word. So we are dealing with sampling distribution. You can tell you are dealing with sampling distribution right away because of this. That word, that phrase, right? So the question is about a sample mean. Whenever the question is about a sample mean, you are dealing with a sampling distribution. Whenever the question is about an individual subject, then you can use a population distribution. But since the question is about the sample mean, we need to use sampling distribution. So let's go ahead and use that. For sampling distribution, mean is the same, which is 108 inches, right? 108, and the standard deviation is going to be standard error, right? Not standard deviation, but standard error, which is 0.4 divided by the square root of that sample size, which is 43. Are you clear?
Show that. Can I see the divisions?
Oh, this is square root SQRT. No, that's standard deviation 0.4 divided by SQRT, square root of n, which is 43. Okay. Yeah, SQR 0.4 divided by SQRT of 43.
Just how many boards? Right?
Yes, sample size. You see, we are using standard error here, okay? That's because the question is about a sample mean. And the question says, what does it say? 108.11 inches or more. So 108.11 inches or more means this right here, that part. Right? And the probability is 0.03. Let's copy that. Round to 4 decimal places. 0357. Okay. Now the second question is saying that now the second part is testing the veracity of the claim. You know, based on this answer, based on this probability, you can check whether or not the claim is no, what is the question saying? The seller claims appear to be yes. So based on this, it's a very, very small probability, right? Do you see that? It's a very small probability. So if the question, if the claim was true, then so this would not have come out to this to be this low, right? The probability. So the seller's claim, that's why turns out to be inaccurate. The sample mean should be considered unusual, yeah, because the sample mean had a very low probability. It's unusual because if the probability of taking this sample, since this is less than 5%, right? Yeah. Okay. Now the keyword is an individual board. Now we are not looking at a sample mean here. So this part C asks you to use population distribution because the question is about an individual board, not about a sample mean, right? So whenever the question is about an individual, individual item, you need to use this here, just plain old standard deviation, not standard error, right? It's 0.4, so we'll just use 0.4 there, and
Inches, right?
hmm?
That was the inches, the 0.4 inch.
Inch, yeah,
Standard deviation.
inches, yes. So with the length of, would it be unusual to have an individual board with a length of 108.11 inches? Well, you see, actually here we could do the same thing, right? It looks like it's not that unusual in this case, right? It's unusual to have a sample mean that high, but it's not unusual to have an individual board with that length, right? But the question is phrased slightly differently, but it's equivalent. The question is phrased this way because this is within 2 standard deviations. That's what it says. So it's not unusual, right? It's not unusual to have an individual board of this length because it's within 2 standard deviations. Within 2 standard deviations mean what? Within 2 standard deviation means so standard deviation is 0.4. So from mean is 108. So within 1 standard deviation means 108.4, and then within 2 standard deviation means 108.8, right? See that? So up to 108.8, it's still usual zone.
And what did we plug in? Did we plug in the score or the? I was right.
Yeah, we plugged in the score because we are looking for whether that is usual or unusual, that score.
And that was in the question piece?
Yes.
I didn't see that number. I was just trying to figure it out.
Yes, it's right there, right here. Are you clear? What I'm saying is this probability being more than 5% is equivalent to saying that it's beyond 2 standard deviations. What did I say? This probability being more than 5% means it's within 2 standard deviations actually. So beyond 2 standard deviations means that probability is very low, 5%. Clear, everybody? So since this probability is very high, so it's within 2 standard. It's not beyond 2 standard deviation, right? Beyond 2 standard deviation is the unusual zone, right, or extreme zone. So in this case, it's still in the usual zone. So so that's how you answer it. No. So this would not be unusual because it's still within 2 standard deviations. Are you clear about this? Okay. All right. See, that's how. So we play with distribution, right? Different kind of distribution: normal distribution, sampling distribution, standard normal t, binomial, normal approximating binomial. But the idea is the same, right? Computing probability corresponding to a score, or score corresponding to a probability. So I think this will complete this distribution questions. Now let's move on to confidence interval questions. So when we are dealing with confidence intervals, let's see. So there is something called confidence level, right? And corresponding to a confidence level, we have a critical value, right? So for example, what's the critical value corresponding to 80% confidence? So how do you compute that? Again, the same idea, right? So we are looking for a score. So z means this is 0, this is 1, right? That's the z distribution. And when we are looking for the critical value, you are looking for the 80% area in the middle, and these are the critical values, right? So we only use the positive one because the other one is a negative of the same thing. So this is the critical value for 80% confidence.
And when you went to the calculator, it's the stat calculator normal?
Yes. Yes, it's a normal distribution. It's a standard normal. But you can use any normal distribution using stat calculator is normal. For standard, you just need to put mean 0 and standard deviation 1.
And you said you only use the positive?
Yes. Yes. Round to 2 decimal places, 1.28. So that's how you find the critical value. And critical values are important because that's how you find confidence interval. Okay? So let me go back to the board a little bit here. Let's see. So, all right, so let's erase all this. Okay, so here is a population distribution, right? And you don't quite see the population distribution, it's hidden. What you see is actually a sample distribution, a little sample, right? And you get a sample mean. And through sample mean, you estimate the population mean. Since it's a big distribution, it's hidden, or it's like unseen. So we just get a representative sample of this, and we say that this estimates this, right? And in order to make this estimate better, so what we say is that, well, why don't we estimate by an interval? Put a margin of error around it, like this. So this E is margin of error. So confidence interval is computed using margin of error. we just subtract it to get the lower left end, and then we add it to get the right end, and that gives you a confidence interval, right? This margin of error is, of course, based on confidence level, right? So if the confidence level changes, this margin of error also changes. So this margin of error is computed using this critical value corresponding to the confidence level times standard error. Standard error, which is, is sigma divided by square root of n, right? That's the formula. So for most computations of confidence level intervals on this test, you will just use, and you can find this just like last time you found it using stat calculators and then distribution, right? Normal or t, right? And then you will find the middle area C.
So you're saying either normal or t, depending on what they're asking?
Yeah, depending on.
Those are your two distributions.
Yeah. So for example, if C is 95%, then you'll put 95, and then this is going to be your either ZC or TC, right? Depending on there is this 95% area, right? That's how you find the critical value. And sometimes you have to find this in order to compute the sample size, right? So there are some questions, there will be some question on this test where you will know the margin of error. This will be given to you. You will also know the standard deviation, and also you will also know the confidence level, but you will not know the sample size. So how do you compute sample size in that case? Well, in order to compute it, so you need to use a little bit of algebra. You need to recall some of your college algebra skills here. So let me use a different color here, maybe blue. So here the formula for E is ZC times that. So if you use a cross multiplication property, then square root of n is going to be ZC times sigma divided by E, and if you square both sides, you get square. Okay. So you will use that. Let's see which question here. Number 43. People were polled on how many books they read the previous year. How many subjects are needed to estimate the number of books read the previous year within one book? Within one book. See, when it says within one book, that's your margin of error with 99% confidence. Initial survey results indicate that sigma is given. So sigma is given, E is given, C is given, 99% confidence. So first thing let's find the critical value corresponding to 99% confidence. So that is just putting 99 here. So it's 2.5758, right? And then once you find that critical value, come back here and do the computation by hand or using your calculator. So it's 2.5758 times what was the margin of error was 1, but what was the sigma? 19.6. 19.6 squared. So just use your calculator. Can somebody use the calculator here? 2.5758 times 19.6. And find the answer and square that. Square the product.
2548.8.
2548.8. And always round up, okay? Up. Even if it's like 2548.03, you always round up to 2549. And why do we always round up? Because in this case we do that. Because the question, it's also given in the instruction itself. Round up, you see that? Right? So let's write that answer, which is 2549, right? 2549.
So D's always 1, right?
Not always. In this case, it is.
If you don't, if you're not given any, it's always
No, it should be given to you.
Within one.
Yeah. It could be different. Within 2 books, if it says within 2 books, you'd write E equals to 2.
So did you multiply the 2.5758, 19.6, divided by 1, and then that answer you took?
Square, yeah.
Okay.
Yeah, since it's dividing by 1 means nothing, yeah.
Okay. So you just squared that?
Yeah.
Okay.
All right, so that's how you do it. So now, finally, let's do some confidence intervals, actually. Confidence intervals are easy because all confidence intervals can be computed using this, right? Stat, either Z stats or T stats or proportion stats based on what kind of confidence level you want. Proportion stats, and then one sample, and then with summary. With summary or with data. If raw data is given to you, you would use with data. If just sample mean is given to you, you would use with summary. And then under perform, switch to confidence. So check confidence interval.
Can you go over when you use summary or data again? I'm just going to put a little notice like that. So you use with summary when?
Well, you always use summary unless you are given raw data, like a big table of data. So data means like big, table of data that you can, copy and export, right? All right, let's look at number 55. I will look at, and then the others you can do yourself, because in this case we are looking at proportion. See that we are looking at proportion. So when you are looking at proportion, you have to use stat, proportion stats, one sample with summary right here. Okay?
One more time.
Oh, it's written right there, right? So it's
Summary.
it's stat, proportion stats, one sample with summary. So the only time you would use with data is when you have data, you can export. You don't have data. Well, it looks like you have data here, but that's not the useful data. I mean, raw data, I mean. Right? So you, most of the time, you just use with summary. And once you have that, you enter the necessary, parameters and hit perform, and you get your confidence interval just like that. You don't have to do all these, behind the scene computations. Let StatCrunch handle that. So number of successes. Okay, let's understand what we are dealing with here. We are looking for 99% confidence interval for the proportion of adults from the East, right? From the East. So that is 34%. So we are looking at how many successes, means 34% out of 400, right? Yeah, 400 adults from the East were surveyed. So 400 is the total number of people surveyed, and proportional success proportion is the 34%, it says here. So if you put 34%, what do you get here? 34% of 400. 0.34 times 400 here, right? And actually here 400. And then you switch to confidence interval, and then switch, use the confidence level, which is 99%, and you hit compute, and you get lower limit right here. And round to 3 decimal places, and it's going to be 279, and round to 3 decimal places, and it's going to be.
Can we go back to StatCrunch? So number of successes was the 0.34 times 400. You change the confidence level,
Yes.
and then it'll give you the upper number.
That method is this default method. Yeah. Okay. So all confidence questions can be handled like that. Let's do one more, right? One more, maybe T. Because Z, we have done a lot of Z, so let's do T. Let's see. $49. So there is a criteria, right? When you use a T distribution, there is a very clear criteria. So you use a T distribution when sigma is unknown. Like in this case, sigma is not known. So this standard deviation that you have been given here is sample standard deviation, right? Population is the key word, right? If you look for population, if you don't see population standard deviation, then you understand that to be sample standard deviation. So when sample standard deviation is given to you, your sigma is unknown. So when your sigma is unknown, then you can, and then it's normally distributed, then you can use a T distribution. Okay, and when that is clear, then you go to stat, T-stat, right?